Hello. Hello, sir. Am I audible, sir?
Yes, ma'am. Yes, ma'am. Shall we start, ma'am?
Sorry, sir. I told you, no, first hour for me class, sir.
No problem. No problem, ma'am.
Now only I came. Okay, sir.
Okay. No problem. Good morning to all. Once again, I welcome you all for the third day session of FTP and Demystifying machine learning algorithm using Python. Dear participants, due to some inconvenience, small changes will be made in the session. Tomorrow's first session is preponed now, and today's first session will be postponed to tomorrow's morning. Let me welcome our today's resource person, Dr. S. Kavipriya ma'am, Associate Professor, Department of CSE, Left Coast Engineering College, Sivakasi. She is having 16 years of experience in teaching. Her area of specializations are wireless sensor networks, IoT, image processing, and machine learning algorithms. She has published more than 15 international journals and 9 international conferences. She has published her research paper and 6 national conferences she has participated. She received Elite Gold Award, Best Paper Award, Best Project Award from various professional bodies. It's my immense pleasure to have you, ma'am, in this forum. I welcome you once again, ma'am. Let I hand over the platform to Dr. Kavipriya, ma'am, please.
Thank you, sir. Thank you for your introduction. Shall I start the session, sir?
Yes, ma'am. Yes, ma'am.
Is video is necessary,
yeah,
sir?
I will. No, ma'am. No need of it. I will start the recording.
Because for online classes, data problem will be there. No, so not.
No need to switch on your video.
Oh, okay, sir. Thank you. Okay. Okay, ma. Very good morning to one and all. Let me present. Okay, very good morning to one and all present here. I am Dr. S. Kavipriya from Google-colab Engineering College. So I thank management of Ramco, HOD, my guide, my professor, my friend, Dr. K. Vijayalakshmi of CSE department. Okay, no words I can say what is the relationship between her and myself. Okay, so she is my sister or she is my friend, whatever you want you can take the relationship between myself and the professor of CSE. She is such a nice person she is. I have no words to explain how she helped in my career, both professional and personal. Always I am related to her, and I will never say no when some question is something is asked from the department of CSE. That is because of Dr. K. Vijayalakshmi only. So she is bonded or not, whatever help you ask from her, surely she will do, and she will never expect anything back from you. Okay, so she is the only person who she made me to finish my PhD. Okay, so my heartfelt thanks will always with her. So thanks for the opportunity given, sir, Gomati Nayakam, sir. So since Madam was there, I was most known to all the persons working in AJIT. Even though it's a small college, the initiatives taken. Even I saw the schedule here. It was that in the schedule it is given. It was from the AA Research Lab. Okay. A tremendous improvement for such a developing college. So they have created a lab with some IITs and they are running this program. Heartfelt wishes to them, for the organizers of the course, because everyone is running behind the machine learning, AI, artificial intelligence, robotics, everyone is there. So it's a right time to start AI research. But the funniest thing is the word artificial intelligence was there still starting from 1900. Everyone is talking about artificial intelligence. Okay. But still, I don't know, suddenly there is a crush has come now. When I was studying computer science, I had this paper AI, artificial intelligence. And I don't know any one word from that A, but I got 85 marks. That is the first beginning of the word A. And most probably, when I joined Kalasalingam, I got my paper also, first paper to teach the students, the same A. Okay. So to my better knowledge, since because when I was studying, even Magam is enough. But when we want to teach my students, we want something to make it clear, because there is a difference between studying, learning and teaching. Okay. Actually, I studied when I was in UG, the paper Artificial Intelligence. I cannot say it is teaching, because even at that time I was not very clear, but I made my students to pass. That's all. Okay, when I was there. So later I joined in WebCo after completing my ME. That time only I get a chance again to implement data mining algorithms. Okay. I didn't handle AI paper because unfortunately I joined an IT department. CSE is having artificial intelligence. IT department is not having a support paper. Okay. And now only in this semester only I was shifted to computer science. So I think I will handle again AI. So that is a lot of difference when I studied AI for research purpose. Because years are gone, I have done my PhD and I want some AI techniques to implement. Okay, even now I can say I am not good in AI, but to somewhat I can give AI. Most of the time we have a confusion. What is AI? What is machine learning? Okay, what is evolutionary algorithm? All are one and the same. We feel like why they have separate data mining, everything. In data mining also you study the classification clustering. In machine learning you study classification clustering. AI again you study the classification and clustering. Why they are having a different name? Why they are having a different name? See, actually AI is broad one. AI is broad area. Okay, so AI comprises all this. Machine learning algorithms is one part. Data mining is one part of AI. AI is the overall one, the environment that makes us to work in data mining and machine learning. So if you study AI, it is enough. So in the AI paper, we may feel it difficult to handle, but in AI paper, they will start with probabilities. Because when you say it's all calculations. See, when you meet a person for the first time, see, now Sir is introducing me. Why he is introducing? I can start the session by myself, no? Why he is introducing? He want to give a vision on me. Okay, so how good a person is. Okay, on learning the vision, on seeing this profile, some of you may think that, okay, let us hear from her what she is going to say. If my profile is nothing, you may think that, okay, he is also a junior like me, so he may not have any experience. Okay, he may not have any experience. So we will leave the session. Simply we will on the session and we will sleep. Okay, no need to discuss anything, no need to hear anything. So it might be our choice. So that is how and the experience talks. Okay, so before moving into the session, whether others said or not, I don't know. Normally, I teach database management system, advanced databases, data mining, data warehousing, and machine learning algorithms here. So I want to make sure one thing because I randomly ask questions to students. Okay, some of them will not answer properly. So I want to make it clear first what is the data. Okay, so data is available everywhere, not only here, there, whatever it is. Data is available everywhere. Everything in this real world is called as a data. Okay, everything in this real world. And the data, when it gets processed, then we will say it is information. For example, there is an accident. Okay, so if I say 10, 20, 30, it is a data, no doubt it is a data. But when I say processed data, what is a processed data? In 1970s, in Madurai to Rajapalayam Road, near Kallipatti, there is 10 accidents. So I collect more data. What is the place? What is the year? I collect some related data and I tell you this much things. Now you will be very sure that, okay, so this is a data about accident. Okay. So a teacher is teaching class. It is just a data. But only when we say some example, that is when we try to relate unknown things with known things, then the data will become information. Then the data will become information. Okay, I got some information when I attended this class. Okay. All information will not develop knowledge in students. Knowledge comes by experience. Very good. Okay. So I say, if you touch the fire, it will hurt you. Okay, so unless at least for one time, if you have touched the hot material and you experienced by yourself that hot materials will hurt us, you will never accept that it will be hard. That is the problem. Okay, so for that reason, knowledge comes out of experience. Knowledge will never come out of simple data. It will come out of experience. Okay. So what is the next level of knowledge? Any guess? Can I get some answers in chat box? Jeeva Kartikeyan. Good morning. Very good morning. What is the next level of knowledge? That is my question. Any guesses? I think all went out. Okay, so the next level of knowledge is intelligence. Okay, so all the people who are knowledgeable are not earning marks. So when you apply your knowledge for another application, experience in the data we get knowledge. Knowledge we acquire by previous experience. What is intelligence? But from the present in the knowledge, I apply things for another application. So if you apply, you are intelligent. So நான் இவ்வளோ படித்தேன், இத்தனை இது படிச்சிருக்கேன், இது வந்து யூஸ்ஃபுல்லாக இருக்கும் அப்படின்னு அப்ளை பண்ணேன்னா, then that becomes your intelligence. Then what is artificial intelligence? Artificial intelligence is humans are always intelligent, no doubt. Okay, we are intelligent. Okay, so we process many things, we calculate, approximate. So that based on we make decisions. Okay, based on the goods and bads we get, we do some calculations and we do some decisions. What is artificial intelligence? We make our machine to think like us. So recently Google has combined with Lewis and they have released Google Shirt. What is the purpose of Google Shirt? You need not take your phone out. Okay, if you touch the sleeves of your shirt, you can answer your phone while you are riding. Okay, no one knows that you are talking in phone. Okay, so it is an intelligent device. Okay, they have in foreign they have one jar. What is the purpose of jar means? It will tell you at what date you bought that grocery, whether all the contents in the grocery is good or bad, it is working or not, good or bad. Okay, and what time you want to replace, what is the health content of the grocery. Okay, and even the smart jar will converges, like shrinks based on the amount it has. If it is having less content, the cap of the jar will shrink to itself. So we are making things it cannot think. Why we say that things it cannot think? A bike, smartwatch, okay. So everything are things. So again, IoT and this are all so much integrated. In IoT also we apply machine learning algorithms, we apply AI, we apply sensor networks. IoT, I can say it's like a fried rice, which is a combination of all vegetables, or it's like a vegetable biryani. Understand? Okay, so this is a combination of all. So we try to simulate our machine to think like us. So that is your artificial intelligence. Okay. Now it's a broad area. If you want your machine to think like that, you need to code your program. Okay, you need to code it. Okay, how will you code your program? So using some algorithm. So what are those algorithms? It may be a data mining algorithm. What is the purpose of data mining? It is trying to analyze your data. Okay, it's the basics of data analytics. Data analytics, again, it falls in the same EA. Okay, so why you want to analyze data? You want to predict something. What do you want to predict? To do something. Okay, before you purchase a TV, you see reviews. Okay, whether this TV is good or bad, we see reviews. So for making decisions, we want to estimate or predict something. Okay, so for those predictions, we have some algorithms. And all these algorithms, whether it is termed as a data mining algorithm or machine learning algorithm, is broadly categorized into, when you have a data, it can be categorized into either I study a classification algorithm or I study a clustering algorithm. Broadly, any algorithm you take, it may be an evolutionary algorithm. You might have heard a subject name evolutionary algorithm. It may be an evolutionary algorithm, it may be a data mining algorithm, or nowadays they are talking about nature-inspired algorithms. All are algorithms that is helping you for learn your machine. Why you want to make your machine to learn? You are in the field of artificial intelligence. Robot, if it wants to detect the bomb, you have to code it. As a computer engineer, we have to code it. For coding, we need some algorithm. For those algorithms, we stick into mining algorithm or nature-inspired algorithm or evolutionary algorithm, whatever you want, you can say. Okay, GA, genetic algorithm, is a part of evolutionary algorithm. Why it is named as evolutionary algorithm? Again, it is an algorithm for AI. But evolutionary algorithm, why it is named? Because it is based on the evolution of human species. Darwin's theory, survival of the fittest. That's why I name it as evolutionary algorithm. Particle swarm optimization, you might have seen into your papers. Why it is named as nature-inspired algorithm? How a bird is flying, like that we converges our algorithm. So it is on seeing the nature I was inspired, and I'm converting that into one algorithm. So they name it as nature-inspired algorithm. Why these are called data mining? Because there is tremendous amount of data present. You see your WhatsApp folder, many images, relevant or irrelevant, multiple WhatsApp groups. Okay, so we are having a tremendous amount of data. So we don't know which is good or bad. Simply you think of one Sunday you want to clean your shelf. Okay, that is not cleaned for say 2 years to 3 years. How dirty it will be. So we want to remove all that and we want to make what is the apt data you want. Okay, so for that I go for data mining algorithms. Okay, so the name is different, but all the algorithms can be categorized as either it is a classification algorithm or it is a clustering algorithm. So what is classification? Okay, what is classification and what is clustering? That will be the first thing. Okay, see, for example, I completed my 12th. I want to join a college. So I go, there will be, n number of colleges. Say in Tamil Nadu, there are 600 colleges. Okay. So out of the 600 colleges, I pick one. So, yes. Then inside the college, there will be, say, 7 departments. Triple E, C, Civil. Like that, I have 7 departments. Okay. So out of that department, I choose, say, one. So what is the thing you are seeing? The classes are fixed. Say I have chosen CSE. Okay, I have chosen CSE. Now, if I have chosen CSE, so when I enter into the college, I have to sit in CSE only. The class is fixed. And CSE is having 3 sections. Then I will have A, B, C. 3 sections I will have. If you are categorized in B section, daily you have to go and sit in B section only. So this is classification. What is the similarity you find in this application? The similarity we find is the classes, number of classes are defined. In Tamil Nadu, there are 600 classes, 600 colleges. It will have a class name, say Ramco, Medco, NEZ. Okay, or in Andhra Pradesh, these are the 6 many colleges. So the output we know, I have to fall in any one only. I cannot ask a new course. If the college is having 7 courses, out of the 7 courses, I have to fix in one course, which I like. That is called interest. That is what we say similarity and dissimilarity. Okay, so based on one interest, I choose one. But once I chose the college, I should not leave it. Okay. So the class is now fixed. Okay. So now I am fixing the class. The number of output is fixed. Okay. So if I show you a picture, it should be a cheetah or tiger. You should not tell me an answer that is different from these two. Okay. Yes or no. I'll say 1, 2, 3. No other choices for you. The number of classes is fixed. Okay, so it is called the classification. What about clustering? Clustering is a beautiful one. It doesn't have number of classes. The output is not fixed. You think of when you joined your college in the first year. Okay, maybe 10 of you may have joined as a friends. Think of whether you continued for the next year. No. Next year, out of the 10, 1 may be left or 2, 3 may be left, because after joining only you find these are the similar features between us, these are the dissimilar features between us. Veerasundaram sir, I am not entered into the slide itself. Okay, that's why it is not moving. Okay, this and all I am generally speaking. Still, I didn't go into the slide because one algorithm only, no. That's what I want to, I normally do the same for students. Before entering into something, you should have a clear vision on something. If you don't have a vision and mission, your objective will not be met always. That's why colleges have a vision, universities have a mission, and obviously in your life, you should also have some vision. Okay. So come back to our problem. Think of when you are in first year. So you might have joined 10, similar or dissimilar. You remove 5 of your friends. Now come in second year, to the 5, another 3 might have joined. Okay, so in the beginning, the class may be bench wise. Okay, normal first year la பக்கத்துல இருக்கிற பையன்கிட்ட மட்டும் தான் பேசிப்போம். The person who is sitting near to me only I will talk. Think of in second year, it will be changed. Think of in third year, this person didn't give me observation, this person didn't give me record. Now the group has been changed. Like that, it will keep on moving. So think of final year, you will get a different friend. Now you think of how many college friends you have now. It's called the clustering. You belong to one cluster earlier, now you belong to a different cluster. Even you think of here the vegetables you like. In your childhood, you may like brinjal. Now you may dislike it. So based on a similarity and dissimilarity, the clusters will develop n number of classes. The number of classes is not fixed. The objects that belongs to class is not also fixed. One time it will be in one class, and another time it will be in another class. Nothing is fixed. Okay, so that is your clustering. So any algorithm will fall into classification or clustering. Okay, so now come to our topic. My topic is namespace. It's a classifier or a cluster. It's a classifier. Namespace classification algorithm. So I have a fixed number of classes, like your decision tree. All of you might have known about what is a decision tree. So like our decision tree, we have a fixed number of classes. So I have an input, and I know that only these are the allowed outputs. So I have to process the input such that I am having the output should fall only to these classes. Okay, so based on some calculations I do. Okay, so now I will move to my slide. Okay, so this is my contact information. If you want any help, you can contact me. Okay, so normally when we see some applications, we may like to do something. For example, we get an email. We want to predict whether it is these are all some real-time applications. We want to predict whether it is a spam or not. And when you go for a medical diagnosis, okay, so the doctor will ask for a list of symptoms. Based on the symptoms, he will predict whether the given patient is having a disease or not. Like nowadays, they are testing for corona or not. Like that, they will decide. Okay, then what about the weather prediction? Every day they are telling in news, today it may be sunny, today it may be rainy. So the weather can be predicted. Okay, so these are some real world applications we like to do. Okay, so there are 3 methods to establish a classifier. Already I told you what is classification and what is clustering. Classifier is quite easy compared to clustering. So you model a classification rule like decision tree. See, SVM can be used as a classifier, can be also used for clustering. KNN, okay, SVM, it can also be, all clustering algorithms can be used for classification also. Okay. If you go for real world model based classifiers, then namespace is the very good one. Okay, so A and B are called as discriminative classification, whereas C is called as generative classification, because we apply our probabilistic model for the data to get the classes. So direct calculations. You know what is the probability, based on that we calculate. If the probability is high, we choose to that class. If the probability is very less, we choose to another class. Okay, and B and C also, it's probabilistic. B is a multi-layered perceptron, neural network. That is also, it is a probabilistic based classification. Okay, so this is the basics of your probability theory. So what is the prior probability? P of X. Okay, so what is the conditional probability? P of X1 given X2. P of X1 given X2. P of X2 given X1. What is the joint probability? P of X based on P of X1 comma X2. Okay, and this relationship can be explored as P of x1 comma x2 is explored as P of x2 given x1 into P of x1 or P of x1 given x2 into P of x2. That is the relationship when you want to combinedly execute your P of x, joint probability. So for joint probability, you should know what is the relationship between. So this we have already studied in probability theory. Okay, and now you will check whether it is independence. Why you want to check independence? Because why it is taking independence is always the Bayesians is going for independent value. Okay, probability is independent because you are not deriving the property from another. The probability theory is not working for derivative. Without output, the output of another thing is given for input of this. Like that, we don't have. Okay. Okay. So that is your independency. Then what is Bayesian rule? Okay. So this is a Bayesian rule. Bayes is a scientist. So he defined this rule. Okay. So P of C given X is equal to P of X given C into P of C divided by P of X. That is posterior probability. C எப்படி predict பண்றதுனா I know prior probability, that is P of X given C into, this is my likelihood, and into my prior probability, and P of X I know already, that is my prior probability. No, prior na before starting. Okay, prior na before starting. Okay. So to recall your probability basics, you can have like this. Okay. So we have a two-sided dice. When they are rolled, you could end up with following occurrence. Dice 1 lands on slide 3, dice 2 lands on side 1. 2 dice sum to 8. Okay. Now what is P of A? What is P of B? What is P of C? What is P of A given B? Okay. 1 minute. Okay. So in your free time, you can estimate all this just to recall what is the probability. We all know, just for recall, you can make use of this sum. Okay. So why we need this probability? Okay. See, for example, a Dr. Fox example, so a robot want to decide whether the door is open or not. Okay. So it applies some measurement about a room, and you want to calculate based on the measurement whether the door is open or not. Okay, so it is a prior one. Is that I know the measurement, that is the prior probability. Posterior is whether the door is open or not. Okay, so open, when it is open, what is Z is diagnostic. When Z is dead, it is open, it is casual. You should understand what is the casual reasoning and what is diagnostic reasoning. Door open இருக்கிறப்போ what is the measurement? It is diagnostic. If the measurement is this, whether the door is open or not, it is casual. So normally casual is easier to obtain. Okay, because with the measurement I can easily decide. But diagnostic is somewhat you want to calculate. That is what we are doing here. So diagnostic we are going to optimize. Okay, so what is P of Z and what is Z given open? So which is the casual that I do with counting the frequencies. What is the frequency? Number of times it is occurring in my data. When this is the condition, how many times the door is open in my database? Okay, I look into my database, I feel how many times, if this is the condition, how many times the door is open. If this is the condition, how many times the door is closed? So I can count the frequencies. Okay, so an example how to evaluate. It is given, is that given open is 0.6, not open, that is 0.3. Okay, so what is my open come X, Z maybe, Z given open into P of open. So this I calculate like Z given open into P of open plus Z given not open and not open. Okay, that you have to calculate. So this I have explored the problem. Okay, so this I am calculating and I am finding that is 0.67. So since the probability is above 50%, I say there is a probability that the door is open. It is above 50%, no, closer to 1. So I say the door is open. Okay, so this is how we do probabilistic classification. So when we say have some prior knowledge, we try to estimate what is your posterior one. Okay, so I know all this value. Is it in the value இருக்கிறப்போ அது ஓப்பனா இருக்குமா இல்ல க்ளோஸ்டா இருக்குமா? So that I know. So from that I am trying to calculate what is the posterior one. Okay, so it is a discriminative probability classifier. Your model is a discriminative model. Okay, so for many medical applications they will use. Normally they will use discriminative probability classifiers for predicting cancer, predicting winning more like that. Okay, so this is a classification. So maximum, our objective is to map the classifier rule, that is maximum a posterior. So we will get a good rule if you use such type of probabilistic classification. Okay, so the difference, you see the discriminative model is C given X, that is the generative model will say X given C. Okay, so the reverse. So now come back to application of this. Okay, so consider a very simple data set. Okay, one field and one class. So I am checking P34 level. If it is high means it is a cancer, medium means it is a cancer, low means sometimes you are getting a cancer. But here for 2 lows, no. And then for medium, 1 time we got no. 2 times we have got yes, and 1 time we got no. For high, 2 times we got yes, and 1 time we got no. For low, 3 times we got no, and 1 time we got yes. So it's a simple one. Okay, suppose a new patient is coming with a blood test. His P34 level is high. So now we want to predict whether he is we want to guess whether he is a prostate cancer is there. Okay, what to do? So it is useful to know a probability when cancer is equal to yes. So how many times the cancer is yes? 1, 2, 3, 4, 5, it is 5. What is the total number of rows in the data set? 10. So 5 by 10, it is 0.5. But this I calculate only how many times I got thing without considering the prior information. What is the prior information? What is the P34 level in the blood test? Any prior information, without any information, we are just seeing what is the probability of getting cancer. No other information, that is 0.5 by 10. Now I want to see my person is having pH is 34 as high. So I want to predict when cancer is Y, whether the cancer is yes, when P34 is high. The probability that cancer is yes, given that P34 is high. So now I want to calculate this. How many times the cancer is yes? So I already told you, you do it by counting the frequencies. How many times the cancer P34 is equal to high? In the total set, how many rows is having P34 high? 3. Out of this, how many is having cancer? 2. So 2 by 3, what is that value? 0.67. Okay, now I say when there is a P34 as high, what is the probability that the cancer will not come? Only 1 by 3. So 1 by 3 is 0.33. So which class value is having higher probability? 0.67. So I say this person may have prostate cancer. Why is the reason? Maybe. Okay. So now I have another class. Say maybe. Okay. Now when yes, what is that thing? So now 2 by 4, that is 0.5. Okay. When P34 is high, how many persons is yes? 2. I added a new row, maybe. Okay. Now 2 by 4, that is 0.5. When this cancel is n, that is 1 by 4, that is 0.25. Then C is equal to maybe given 5, that is again 1 by 4, that is 0.25. Again, which is having higher probability, that is 0.5. So, Y is the winner. It says that he may have a prostate cancer. Okay, so in general, you can have any number of class values. So in the previous, what are all the class values? Yes, 2, no, only 2 classes. The output is the class value. I have only 2 ultimate classes, yes and no. Here, how many classes I have? 3 classes. Yes, no, maybe. The values in the output column is called as a class. Yes, no, maybe. Okay. This is the essence for naive Bayes. You may ask me a question. Bayes is the name of a scientist. He devised this equation. I told you one equation. This one. P of C given X is equal to P of X given C. Okay, so that this Bayes theorem is proposed by the scientist Bayes. So it is a naive Bayes classification. You may ask me a question. What is the meaning of naive? Okay. Naive means without any experience. Okay, naive user, database management system, naive user. He doesn't have any knowledge about the system. He doesn't have any prior knowledge about the system. So why it is called the naive Bayes classifier is called a naive means it deals with independent variables. See, this is the biggest interview question ever asked. There are n number of algorithms. How will you choose an algorithm? We know there are n number of classification algorithms, n number of clustering algorithms, or you can say n number of evolution algorithms. How will you decide an algorithm? So you should know what is the characteristics of an algorithm. So this is the model based. So if I know the probability very well, I can go for naive Bayes. Another reason to choose naive Bayes model, I can never say naive Bayes is ever best among all the machine learning algorithms. So whenever there is a question which classifier algorithm is best, you ask them what is the application. You look into your database. For different application, maybe your namespace may be wrong. This is what an interviewer wants to get an answer from you. Okay, you have to decide choosing algorithm based on the nature of your data set. Okay, so you have to decide based on the nature of your data set. So if you have independent variables, that is one feature is not dependent on another feature. Okay, then you may choose naive Bayes classifier. Okay, now it is your Bayes theorem. So now I was telling you simply, now I go for my Bayes theorem. Okay. So what is my Bayes theorem? A given B is B given A into P of A by P of B. Okay. So it is easier to get things on the right. And we want to predict things on the left. Okay. So class X field value is equal to F means I will first calculate field value F given class X into probability of class X divided by field value is equal to F. Okay. So for a one non-class field. DMML means data mining machine learning context. Okay. So we want to check for every class and we want to give which class is giving the highest value. Okay. So we can compare field value is yes. What is P of S? Field value no. What is P of no? And field value maybe. What is P of maybe? Okay. So and that's what we do for the naive Bayes algorithm will do for a one field data set. Now my real database is not going to have a single field. It will have many fields. Okay, I understood how to do with one field. One field it is very easy. Okay, only P34 level, I want to predict the P34. But really we won't take decision with one. We will take decision with multiple criteria. For example, you want to choose a person for a job. I want to choose a person for a job. What I will do? So I will say, check what is his 10th mark, what is his 12th mark, what is his semester mark till 7th semester. Is he having any co-curricular activities? Is he has been an office bearer in any one co-curricular club? Has he earned the first prize in paper presentation? Has he done any project presentations? Okay, so I will estimate in multiple ways. He is having any extracurricular. Then I go for personal also, HR interview. Whether he is fit for the job or not, I will try with this many options. So in the real world classification, the classification may be because of multiple reasons. Okay, so here I have three values, P34 level and bed, P61 level and BMI level. So now a new person is coming for a blood test and he is having P34 as M, that is medium, P61 medium, BMI as high. I want to guess whether he will get a prostate cancer or not. So now how it will work. Okay, so P34 is medium and yes, P61 medium and yes, P BMI H and yes. What is the probability of cancer? Yes. Same thing with what is the probability of having cancer? No. I want to calculate both. M given Y, M given thing. So what is the P of 34 equal to medium given Y and yes. Okay, in the field of prostate, I want to have yes. So medium means 3 rows. P34 level, no. So 3 rows. So here 2 by 3. What is P61 medium? This is P61 medium. It is 0. Okay. BMI high and yes. 1, 2, 3. Out of this 2 is having. So 2 by 3. What is the P of cancer is equal to Y? 3, 6, 9, 10. So 5 by 10. P of cancer is equal to Y. Similarly, for medium, no. That is 1 by 3. P61, no. That is 2 by 2. That is 100%. High and no. 1 by 3. And cancer, no. It is 5 by 10. Understand? Okay. I want to estimate how many times. So that is what I am having. So now out of this which is having the highest value, this has become 0 and this has become 0.8. So whether he has the probability to get cancer or not a cancer, not a cancer. And on the probability, look into the probability, it is 0.08, 8%. 8% is more nearer to 0. Okay. 8% is more nearer to 0. That is the biggest problem in this base. In the problem, madam, when one field is 0, the entire field is moving to 0. How to avoid the 0? That's a big question we have. So one possibility is we can have a logarithmic value and we can decide. Okay. Now -4 and -2, which is higher, again -2. But we didn't get 0. Understand? So you can make use of logarithmic values. The output you take and apply log. It's a simple solution to eradicate the 0. And add 1 to the field. For example, here for 0, I have added 0.001. Because 0.0001 is not having much impact in my research. Okay, so I have this values. Out of this, I decide which is higher. The -2 or -4 is higher. -2 is higher, so he may probably not have a prostate cancer. I decide. So we can use this logs for this. Okay, so in general, I can say naive maybe direct probability calculations, or I can apply a log of these probability calculations to avoid that 0 condition probability. So this is called a 0 condition probability in machine learning. When one term becomes 0, everything becomes 0. Okay, and you choose which is highest of these. Okay. So why we want to go for Bayesian classification? That is the biggest question. This is a statistical classifier. We have a strong foundation in probabilistic prediction. So we predict class based on a statistics. Then the foundation is based on Bayes theorem. And what about the performance? When compared to decision tree, so whenever a question performance is asked, never say it is best. Which sort is best, madam? You tell me the application. Okay, then I will say, see, external sorting, merge sort. Is the merge sort is good for already sorted element? No. Okay, so you have to know what is the input. Then only I can decide which is going to give the performance. So my comparable performance with decision tree and neural network, this namespace classifier will work best. Okay, then it is incremental because you can increase and decrease the probability in the hypothesis so that the prior knowledge is getting improved. So when you change a probability, you can again apply a classification and you can classify again. Okay, so this is the basics for name-based algorithm. So this is a book theory. Normally it will, any data, not only for this classification, when you download a data set, you have to divide the data set into learning phase and test phase. So during the learning phase, you give the training data set and you train your model for this input, this is the output. Then during the test phase, that time only you predict whether it is belongs to which class or not. Okay, any data model, whatever may be your model, KNN or whatever it is, first you have to, if there are 1 lakh rows, some 50,000 you can use for training and some 50,000 you can use for testing. So testing is how we predict. For example, here we build the model and we test. Okay, so this is testing. So I'm giving a new patient with 334 as AM, 361 as AM, and BMI as I. So testing is this. So training to build a model. Okay, you have to divide your thing into learning phase and test phase. So another example, for example, here I have play tennis. So these are all the features I have: outlook, temperature, humidity, and wind. And whether they play tennis or not, this is the output. Okay, so this is the days. This will not be considered for any machine learning algorithm because day is not a matter. You will record the whether they play tennis for every day. That's all. So it doesn't have any impact. Okay, if it is Sunday means it is raining. No, if it is rainy season means it will rain. So that's why we leave this. Okay, and during the learning phase, based on individual features, I calculate, I estimate. Okay, so when the outlook is sunny, how many times they played, how many times they didn't play. When the temperature is hot, mild, and cold, when they played and when they did not play. The humidity is high and normal, when they play and when they do not play. Okay, so if play is equal to yes, what is the probability? Then when the wind is strong, how many times they played and how many times they didn't play. So this, see, there are 14 samples. Out of that, yes is 9 times and no is 5 times. So when the humidity is high, 3 times they have played. That is the mean. When the humidity is normal, they have played 6 times. That is the meaning. Total number is 14. So how many times they played? 9 by 14. How many times they didn't play? 5 by 15. Okay. So in the test phase, I give the real data. So when outlook is sunny, temperature is cool, humidity is high, wind is strong, they will play tennis or not. That is the problem in hand. So what I will do, you may ask me a question. All these are having simple one-line methodologies in R or Python or whatever it is. Why do you want to learn all this? The basics behind this. So that is where you fail in your interviews. That's what I tell you. You should know the feature of the classifier. Okay. Unless you know the feature of the classifier, you cannot decide which classifier is best. If there is n algorithms and if you have a standard data set, you should be able to select the best one. Okay. So unless you know the algorithm, you cannot say the answer to this question. You cannot search algorithm as you like. You have to understand what the algorithm will do. See, I went to Infosys for a course, Infosys Mysore. I talked with the Infosys HR. He was telling me this question. Everyone now coming with the profile that I did my final year project in data mining. Then if I ask any question that they don't know, they might have used in MATLAB simply, okay, namespace of the data set, that's all. If you say like that, you will never get a job. You should know what is that namespace classifier is going to do. What type of classifier is this? What is the input you require? Whether your database will best shoot for it or not. If you have a dependent variable namespace classifier, you should never apply for it. Namespace will work only for independent variable. That's why it is said it is names without any prior knowledge. And it is a statistical model which requires probability. Okay, so you should be very clear in all this. Okay, so in the testing place, I give what are the instances. Okay, so I say when the outlook is sunny, how many times they played. When the outlook is sunny, how many times they didn't play. Similarly, for temperature school, how many times they played and how many times they didn't play. Humidity is high, how many times they played and how many times they didn't play. All the played I have to multiply, all the unplayed I have to multiply. So I get some answer, 2 by 9 into 3 by 9 into 3 by 9 into 3 by 9 into 9 by 14, I give us 0.0053. Okay, then 3 by 5 into 1 by 5 into 4 by 5 into 3 by 5 into 5 by 14, I get 0.0206. Now which is having higher probability? Obviously no. So whether they will play tennis today or not, they will know. They will not play. Okay, so this is how the real data will be given in the test phase. Okay, now sometimes what are the issues with the naive base? This only you have to keep in your mind because of this issues only some database you cannot apply your naive base. Okay, so some data sets will have dependent assumptions. Okay, so if there is a dependent x1 and x2 is giving this C, you see here x1 comma x2 then give C, then this namespace is not going to work. Relationship data kulla relationship irundaduna it is not working. Understand? Okay, see for example if my family is having some problem, I will not study. If that is your problem, then you should never use namespace. Okay, the next problem, this we discussed earlier, zero conditional probability. At least all the terms we are multiplying, no? You see here, all S terms you are multiplying and all no terms you are multiplying. So if at least one is coming to zero, your probability will become zero. So that is called a zero conditional probability. So it is a big problem. So one is coming zero and another is coming as 0.002. 0% and 2% is most close. How will you decide which is best? Okay, so to avoid that, normally I gave you another solution that you have to take logarithmic. When you apply logarithmic for the probability, your probability value will change. And you can add a minimal value to that. Okay, for example, I can say 0, you can add 0.0001 to all the values. Why I add 0001? It doesn't have 0.01 percentage difference. It doesn't make a big change in your result. So you can add like that. Okay. And think about if you have a continuous valued input. What is a continuous valued input? So if it is a distinct input, you can easily classify. Continuous valued 10 to 12, 15 to 20. Okay, you have to go for a conditional probability model. So this is the conditional probability model. Okay, so P of X given CA is you have to calculate the average, you have to calculate the standard deviation, and then you have to apply. Okay, so this is having a complex calculations. So for continuous valued input attributes, even you can choose some other classifier rather than your namespace classifier. It is up to you. Because again, you want more statistical information. It needs a complex calculations. Maybe because of implementing this, your classifier may work slowly. your performance may be degraded. Okay, that is why in many papers they will compare. See, I used this many classifiers and I found that only this classifier is working for this application. See, again I repeat, I'm not never telling that this namespace is best. No, I have for my application, my constraint may be different. For some other application, constraint may be different. Whatever the application you have in your hand, you try with some model which is giving you better accuracy, you follow that. Okay. So another example, okay, since we are all computer science, we may have a thinking that whether we want to buy the computer or not. Okay. Now 1 minute. Okay. So the same thing, okay, the data to be classified is whether age is less than or equal to 30, income is medium, student is yes, credit rate is fair, I want to do or not. So you can go through the slide after some time. Another example for the same namespace classifier. I've already given 2-3 examples. Okay, this is what. See, how I am calculating, you see I am adding some 1 by 1003. Okay, adding 1 to each case. Okay, so somewhat I won't get 0. I will get, suppose income low is 0. For that 0, I'm adding simply 1. So this will become 1 by 1003. Why I get 3? Because it is 1 by 1000. For all the 3, I'm adding 1. No. So it is become 1000 is becoming 1003. And 0 is becoming 1. 990 is becoming 991. 10 is becoming 11. So this is called as corrected probability. This is allowed because I told you already, when there is the term probability coming, it is an approximation. So which is simple estimation. So it is allowed. Okay, 0.003 will never get a big change. Okay, so what are the advantages? Training is very easy, it is very fast. Okay, and it is very easy to implement, very straightforward, or just a formula, is or no? So it's just a formula, how many rows is having yes, how many rows is having no. Okay, even the conditional probability you can do. Okay, then disadvantage. The first disadvantage lies in the assumption. What is our assumption for namespace classifier? It is a class conditional independence. Okay, so if there is a dependence, there is a loss of accuracy. Okay, and sometimes the features may be overlapped. When the features are overlapped, your features will not be independent. Your features will be dependent. Okay, your features will be dependent. At that time, you cannot use a namespace classifier. Okay, for example, in the hospital database itself, the dependencies existing among the hospitals and patients, profile and age, family history, okay, whether they have a fever and cough, okay. So even when you approach a doctor nowadays for cold and fever, he will ask whether any of your family member is affected by corona or not. So there is a dependency. And those dependencies cannot be modeled by namespace classifier. Repeatedly, I am telling you, okay. So that's all about an namespace classifier. It is based on probabilistic model, Bayes theorem, formula we know, and I gave you some data sets and how to estimate that we have seen. Okay. Next, we will come back to our implementation. So you see, implementation is not a matter. If you are a research scholar, never choose a language that you never know. Okay, so you can write the same code in Java, you can write the same code even in C. You can do it in MATLAB, you can do it in Python, you can do it in R, whatever language you know you can do. Implementation is not a matter. Why I am telling you this is, don't waste your time in selecting a tool or a language. Understand? Don't do like that. Okay. So whatever language you want, you can choose. Now 1 minute. So I have shown implementation in Python and R programming. 1 minute. Kindly excuse me. Okay, so I have included snapshots of my implementation in Python and R. Okay, so those are best with Python, because why I use Python and R means it is having ready-made packages. You need not worry. Okay, so normally my suggestion is you don't worry too much about how we are going to implement. Okay, first do proper analysis of your data set. Download the proper data set. Okay, and I think in the schedule it is given classification of diabetes. So I downloaded this diabetes data set from Kaggle. There is a kaggle.com where you can download many data sets. Okay, so I downloaded it from the Kaggle database. So whatever you want, you can do, but first collect a relevant data set. Which language is convenient for you, you can use. Okay, so I downloaded from this. Okay, and that data set is having 9 columns, or I can say 9 features: pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, pedigree function, age, and outcome. Now the first 8 features is the input, and the last one is the outcome. Okay, so and the outcome I have 2 classes, 0 or 1. 0 means non-diabetic, 1 means diabetic. Okay, so first we have to import the pandas library. So it is in Python. Okay, so import pandas as PD. Then you can read the data as data is equal to pd.read underscore CSV file. So it is similar to your Excel CSV file. Okay, so you read the diabetes.csv data. It's a built-in data. Okay. So to print the first 10 rows of your data, you can use head of 10 function. So it will say what is available in your data set. So I say pregnancies, glucose level, blood pressure, skin thickness, insulin, BMI. Okay, outcome I told you, 1 and 0, whether there is a diabetes or not. Okay. Then now you want to data type. So before proceeding, we want to use the data type. So they have defined pregnancies as int, glucose as int, and only BMI and diabetes as float. Okay. So then if you want to describe the entire database, so you want to get the statistical, or that is what I told you. Before you proceed with any classification, you should know what is the statistics about data. Okay. So for that, Python has data.describe of. You see here, count number of rows is 768. Then what is the mean value of pregnancy? Glucose, blood pressure. What is the standard deviation? What is the minimum value? What is 25% of data is having? This 50%, what is 75%, and what is the maximum? Okay. So these will give you the nature of distribution of your data. Okay. We normally see that bell distribution. Like that, we will describe our data, skewed, left skewed, right skewed, like that we say. So for that, we should know the nature of your data. Okay. Then I told you have to split the data. Okay. So X may contain the independent variable and Y contains some dependent variable. Okay. So we can import trains underscore test split function. We can separate the columns as data.drop of outcome, comma, this is your feature name, axis is equal to 1. Then Y, data as outcome. Okay. So then you can split the data set using this line. Okay. X underscore train, X underscore this. So using this command, you can split the data into X will be treated as a training data set, and this X comma Y will be split as, you see here, test size is 0.3. So 30% is test. 70% we use for training. Okay. And we randomly choose. So we put random state is equal to 1. Okay. Then you can import for namespace from sklearn. You can have to import a Gaussian NV. Okay. And you can create a Gaussian model using Gaussian NV of built-in function that is available from here, that you have to import. Okay. Then you train the model using X-train and Y-train. Out of that, training alone will go for this. So now you have developed the model. Okay. And predict the responses based on the testing data. So Y prediction is equal to model.predict of X underscore test. Testing data கொடுத்து Y we predict. Okay. Then normally when you do this classification, the very important thing we have to do is we have to check we have to evaluate our model. Evaluate our model now, whether our model is good or bad. For that evaluation, we need some matrices. The very good metrics for classification is accuracy. Normally, we love to get a classification accuracy higher. Okay, so this is a line to get. So you have to import from sklearn metrics, print metrics.accuracy underscore score y-test comma y-print. If you give this, it will print the accuracy. So the accuracy is 78%. Okay, it is good. So it will accurately predict whether a person is having diabetes or not. Okay, so you can predict, and if you want a classification report, so we love to generate a confusion matrix. Okay, so now we can generate a confusion matrix. This is the confusion matrix 128, 18, 32, 53 for the y-test and test predict. So these are the parameters. What is the precision, recall, F1 score, and support. So these are all multiple parameters to check. Okay, so what are the parameters? Normally we go for classification, whether we say whether it is true positive. What is true positive? The person actually having diabetes has to be correctly classified that the person is having a diabetes. True negative, a person is not having a diabetes but predicted as not diabetic. Okay, false positive, he is not having diabetes but he is predicted to have diabetes. False negative, he is having diabetes but he is predicted non-diabetic. Then what is the precision? It will help us to calculate what percent the prediction is correct. Like accuracy, you have these scores also. So it is calculated using a formula true positive divided by true positive plus false positive. Then recall will say what percentage of the positive cases we match. That is, we find how many percent is correctly identified. Okay, so recall is equal to true positive divided by true positive plus false negative. Then F1 score, what percent of positive prediction were correct. Okay, so either what percent of prediction is correct. F1 score will tell you what percent of positive prediction is correct. Okay, so for that we have some, that is 2 into recall into precision divided by recall plus precision. Okay. So you can also implement your names in R. Okay, so for doing in R, you have to load all these packages. Okay, that is required for this. Okay, so you can import all the required passages. In R, to read the data, you should have read.csv. Okay, data, read.csv. Okay, so I have a diabetes.csv data. So this is the thing I had in the desktop. Okay, then name for setting the outcome variable as a categorical variable, whether it is true or false. So you can use the function factor of data outcome level is equal to C of 0, 1 and level C is equal to 0 for false and 1 for true. Okay. Then to study the structure of the data, where we had in Python like that. If you want to study the structure of the data, you put str of data, so it will tell you whether it is integer, num or whatever it is. Okay. Then you say head of data, it will outcome as. So you see here it is not printed as 0 and 1. For 0 I have given false and for 1 I have given true. So like that it will display. Then we have to do data cleaning, additional step. If you want, you can give. So why we want to clean? Because some features may not be ideal. For example, no one will get a value of 0 for glucose and blood. So we want, if there is a 0, then we can treat that as a missing observation. Glucose on the 0 you will never get. Similarly, blood pressure 0 you will never get. So to set the 0 values to not applicable, okay, or I can say null. Okay, so we can use this data wherever I get the 0, you assign the value to be NA. Okay, and we can visualize that missing data using mismap of data. That is the built-in function. Mismap of data is a built-in function. Okay, you can visualize the data. There I told you, you have to understand what is your data. In R, there are multiple data visualization. So you can go for ggplot. Okay, so based on the input. So age, color is equal to outcome. Okay, and geometrical frequency you can use based on the bin width. Okay, so bin width we know. So that we can do and we can plot it as a graph. Okay, so this is the age distribution with respect to outcome. This is it. Similarly, you can use a pregnancy distribution with respect to outcome. So it's a histogram. I have set the bin width to be 1. Similarly, BMI distribution with respect to outcome. So ggplot is in R is used to visualize your data. Okay, so I can understand how it is skewed, how it is. Okay, so I can understand. Then ggpass you can do. So if you use ggpass of data, you will get everything. You see here, this is pregnancy, this is because of glucose, it's because of blood pressure, it is because of skin thickness, and even you get that values. Glucose is between 50 to 200, blood pressure is between 25 to 250, skin thickness is between 25 to 75. Everything you get in a single plot if you use ggpass of data. Simply if you want to explore your data. Then we want to model our data. Okay, so while modeling our data, we will do data splicing. I already told you. What is data splicing? You split your data set into training set and testing set. Okay, so this is your training set and this is your testing set. So you split the data using this create data partition. Okay, 75%. Okay, then training. What is that? And minus index train will be the testing data. Okay, then we get the accuracy, whether it is false or thing. Then we compare the output of the training and testing. Okay, so now you have to model your data for Naispace. So for that you have to import the package. The function is available in E1071. So you have to use library of E1071. So after that you can train. Okay, model is equal to train of. So this is here. So once you have imported, your model will be a namespace. So it is giving you the answer. If you print the model, you will get namespace 576 samples, 8 predictors, 2 classes, false and true. No pre-processing is done. Cross-validated as tenfold. The summary of sample sizes. Then resampling while tuning. How many false accuracy? Okay, kappa statistics accuracy. True, how much is there, then tuning the parameter, what is the thing you will get. Okay. So then I told you, any model after it is created, you have to evaluate the model. So for my data, I got 73% accuracy. Now you tell me, man, why I am getting a different accuracy when using R and when I am using Python. In Python, same data set I used, I got 78% accuracy. I implemented the same thing in R, but I got a 73% accuracy. Why? Where I showed the difference? Have you seen the data set? I was explaining, no, how I split it. Data cleaning layer. Okay, maybe. Because of data cleaning. Up data cleaner, I should get a good performance. 78, 73 Where I showed the differences, I splitted the data into training and testing. No, there is a difference. So when you have more for data, ஒரு ரெண்டு மாடலை கம்பேர் பண்ணணும் அப்படின்னா ரெண்டு இடத்துலயும் ஒரே மாதிரி இன்புட் கொடுக்கணும். நான் வந்து எல்லாமே அதே டயாபிடஸ் டேட்டா செட் தான் I took, but where I changed this, I differentiated number of rows for training and testing. So training the sample குறைச்சோம்னா we won't get accuracy. Okay, so model comparison, your review paper if you are going to write, you want to compare different models for the same data set. Anywhere you should never change the data. All places you should have even number of rows the same. Okay, so that you have in your mind. Okay, so thank you. I think it is almost time. Okay, so I think so I tried only these two because I have only less time for preparation. Okay, so you can install dataset from Kaggle, or you can install, these are some sites where you have your data sets, you can make use of it. Okay, so I always say think like a legend. Okay, so every one person is different, every one of us is having a different quality. So don't think that nothing, I'm zero. Okay, so always think like a legend. உனக்கு நீதான் ராஜா. ஏதோ ஒரு அது யாரு பையன் பேர் என்ன, குட்டி பையன் தனுஷ் சொல்லுவான்ல, எனக்கு நான் தான் ராஜா. அதுக்கு முன்னாடி ரஜினி சொன்னாரா. ஸோ திங்க் லைக் அ லெஜண்ட். ஓகே, அண்ட் ப்ளீஸ் பி ரெடி டு டேக் ரிஸ்க் இன் யுவர் லைஃப். அது நான் சொல்லல, சுவாமி விவேகானந்தா said it. Okay, take risk in your life. If you win, you can lead. If you lose, no problem, you can guide. Because losers will have much experience. If your experience is increasing, knowledge is increasing. If your knowledge is increasing, you will become intelligent. So if you want to become intelligent, take risk in your life. With this small quotes, let me finish this session. If you want any questions, I'm free to answer. Both training and testing should have same data set for all models and all also packages. Yes, that is what I told you. Okay, if you have any questions.
Any questions from participants? I would like to invite Mr. Vignesh Saravan sir to give the formal vote of thanks to ma'am.
Yeah, sure, sir. Thank you very much, ma'am. And I extend my heartfelt thanks to Dr. S. Kavipriya, Associate Professor, Department of Computer Science and Engineering, Coastal Engineering College, Sivagasi. Ma'am, in spite of your busy schedule, you gave a wonderful session to us. So thank you for accepting our invitation and shared your knowledge and detailed ideas on the naive Bayes classifier in ML algorithm, machine learning algorithm. So once again, I thank you for acting as a resource person for this 5 days FDP on demystifying ML machine learning algorithm in Python. So thank you very much.
1 minute, Vignesh. Muruganand Gopalraj has asked a question which is simple. Okay, normally I say I will never answer such type of question. Good and bad, it depends on people. Okay, so R may be simple for me, but it may be tough for you. Python may be simple for me, it may be tough for you. And there is nothing called non-programmers. I am seeing a new term, that non-programmers. Maybe I think you are telling that in electrical field. Okay. You can apply in electrical field or whatever field you want. You can apply all this. See, all are having now ready-made packages and step. Okay, so all are having individual step. So ninga and the basics தெரிஞ்சிக்கிட்டா போதும். Which algorithm you want to apply, that you learn. Then if you go and search, Google Andava is there, you go and search and see Python how to execute. It will give you some step. So on the steps follow pannina, you will implement the model and you will get the answer. So you read the answer, which model is having accuracy, then you can say that this model I have applied. So implementation has now become very easy and simple, whatever may be the language, R irundhalum seri, Python irundhalum seri. So you learn the basics, okay, R basics, Python basics you learn. After that it is up to you. Okay. Have I answered Muruganand sir? Thank you for your question.
Participants, any more questions?
Any questions from participants? Yes. Thank you, ma'am. You can continue, sir.
Okay, sir. Okay, Okay, sir. Thank you, ma'am. Thank you once again for elaborating the session very deeply and depthly. So once again, I thank you for acting as a resource person for this 5 days FDP on demystifying machine learning algorithm using Python. Okay, so thank you. So thank you all participants and thank you resource person, ma'am. Thank you, ma'am.
Thank you all for patient listening my lecture throughout the session. Thank you. Please convey my thanks for the management of Ramco and my philosopher, my guide, your HOD, Dr. K. Vijayalakshmi ma'am also. Thank you. Yeah, and my students also are there, no? So I thank everyone. And I especially thank the organizer, okay, who gave me opportunity to talk these people. And it's very well organized, okay, and all the very best for the continuing sessions also. Thank you, sir. Shall I read that?
Yes, ma'am. Thank you very much personally. Thank you, ma'am. Thank you very much. Okay, participants, you can fill it. Not a problem. It's not mistakes there because swapping the session. That's the reason it's shown like that. I will change it. One more thing, I share the Google Classroom link to you, where already we have posted the recorded videos, so you can use that. Even very soon, within today evening, I will post the other materials also in the Google Classroom.